My name's Chris Gorse. I'm here with Professor John Sturges, and John's been looking at some of the pertinent issues of sustainability. And one topic that you've given some thought to, John, is that of nitrogen. How important is nitrogen? What is the issue at the heart of this?
Well, living tissues and all plant material consists of carbohydrates, fats and proteins. Now, carbohydrates and fats consist of carbon, hydrogen, oxygen. Proteins contain nitrogen, and without proteins, life will not exist. So we need proteins. If we're vegetarians, we need to make sure we eat plant material that contains proteins, things like nuts and things of that sort. We substitute that for our meat, which gives a normal, not diet person the supplies of protein. So nitrogen, being an important component of protein, is an important element. Now, in the world as it is naturally, we know that our atmosphere contains 80% nitrogen, so we're bathed in an atmosphere that's 4/5 nitrogen. However, the problem is accessing that nitrogen. Nitrogen forms a diatomic molecule, N2, and the forces that bind those two atoms together are extremely powerful. Therefore, if you want to split that, it's a very endothermic reaction. It requires a massive input of energy to do it. Now, in nature, how does nitrogen get fixed? Atmospheric nitrogen is inert. It can't take part in any chemical reaction naturally. We can't use it, plants can't use it. We breathe it in, we breathe it out, untouched. In nature, we can fix atmospheric nitrogen in some chemical form in two ways. Firstly, leguminous plants, things like peas and beans, contain nodules on their root systems which can take atmospheric nitrogen and fix it in a chemical form and produce protein, which when we consume those foods, we can then access chemically. They're able to take part in our body biochemical processes. The other way that it can happen is during thunderstorms and during lightning strikes. In a lightning strike, you get a sudden discharge of electric charge, millions of volts, hitting the Earth's surface, and in that instant of very high energy release, there's enough energy there to split atmospheric nitrogen molecules and again to fix the nitrogen in some chemical form that we can use. Now, if you go back 200 years, you come to the work of the Reverend Thomas Malthus, who wrote his famous essay on population. And he'd studied agricultural crop yields, and he realised that England was an agricultural country, and he'd done calculations which showed that while everybody could be fed enough protein in the year 1790 or whenever it was, in future, if the population increased dramatically, and of course by 1790, we were becoming conscious that the world's population was increasing. He therefore said that if, without some way of increasing nitrogen production, mankind would face starvation. People would starve to death because they wouldn't be able to get enough food. Now, some people took notice of what he said and some didn't. The Spanish had a big empire in the New World, and they discovered in places like Chile and Peru cave systems which had been inhabited by millions of bats and seabirds over millions of years. It lived in these caves, and the bottoms of the caves were full to depths of 50 or 100 metres of bat and bird droppings, guano. And this is a very nitrogen-rich substance, very heavily nitrogenous material. And the explorers realised that this would be the basis of an excellent fertiliser, because fertilisers, to make a fertiliser is a nitrogenous material you put on land to help protein matter grow in plants. And they discovered these deposits of guano. And during the 19th century, a whole industry developed, a whole shipping industry developed. A fleet of ships plied endlessly between South America and Europe and the other population centres, bringing back supplies of guano from the caves in the New World in South America. Fortunes were made. The bloke who built that big National Trust place, Tinsfield House, he made his money in this guano business. The bloke who put up the money for Leeds City Council to buy Kirkstall Abbey, he'd also made his fortune in the guano business. So it was big business in the 19th century. However, in 1890, the president of the British Association presented a paper at their annual meeting to the effect that we would be faced with Malthus threat again when the supplies of guano ran out. In other words, once we couldn't get enough nitrogenous fertiliser, we'd now got a bigger population to feed, people would begin to starve. So that was the picture in 1900. And a German chemist named of Fritz Haber developed a benchtop process for synthesizing ammonia from nitrogen and hydrogen. In other words, he was chemically fixing nitrogen from the atmosphere into another substance, ammonia, which can then be used in chemical reactions with ammonium nitrate, which is an excellent fertilizer. It's also a very good explosive, a basic good explosive, but that's another story. He teamed up, he brought that idea out in about 1905, 1906, and he teamed up with another German engineer, Robert Bosch, and he was a chemical engineer, and he designed a process for producing ammonium nitrate in industrial scale quantities, not just a few grams on a laboratory bench, but actually doing it on an industrial scale. And again, it was a very endothermic process. It required a pressure vessel in which you could get a very high pressure, 500 atmospheres, and also a high temperature, 400 or 500 degrees C, so you could get enough energy to rip the nitrogen atoms apart and chemically combine them with hydrogen to produce ammonia. And this process came on stream in 1913, just before the First World War. And that was one of the things that has enabled the increased population of planet Earth in the 20th century to be fed, because we've had a good supply of fertiliser to enable the agricultural industry to grow all the crops that it needs. So that's why nitrogen is important, and that's why the Haber-Bosch process has become very important. The problem we have now is that in certain parts of the world, farmers have overused these ammonium nitrate fertilisers. They've used too much of them. The rainwater has washed them off the land into the streams and rivers and down to the sea. So what happens then is when this water gets down to the sea, you get a local area of highly nitrated water. What happens? Well, algae, another plant form, all this nitrogen enables these algae to form at a very accelerated rate. So you get an algal bloom formed. Thousands of these algae form. They're feeding on all this nitrogen. They feed on the nitrogen and deoxygenate the water. So first of all, you get an algal bloom, and then the water becomes anoxic. And once it's anoxic, it's effectively dead because it won't support life. So no fishes and other plants can live in it. So you then get a dead zone by the end of the river mouth. And that is a problem that's arisen because we've solved the nitrogen problem for fertilisers. Again, it's a sustainability problem. It's something we need to look at for the future. We need to use these things more intelligently and regulate their use more carefully. But that's the reason for nitrogen being an important topic. and one that we need to not lose sight of when we're talking about implementing sustainability for the future.